Today we are going to take a look at how we can graph linear functions. Okay, so we're still talking about functions. And basically we're going to take all those concepts of functions we've been looking at and put them all together into one problem. And we're then going to be able to graph linear functions. Now the key here is that we are graphing linear functions. Okay, so linear functions, when we graph them, are always going to graph a line. So nothing that's curved, nothing that's like going up and down, nothing making a V. We'll look at some things like that later in the year. Just right now we're focusing on linears. So to know that something is a linear function, okay, that means we're not going to see an exponent larger than 1. So it's going to have two variables potentially, maybe just an x, maybe just a y, okay, but typically we'll see x and y. And none of those are going to have exponents other than 1. So it's really important, sort of simple concept to know, but that if we see something like y equals 2x plus 3, these variables really have exponents on them. We just don't write them, okay? So they have exponents of 1. Just like this y also has a coefficient of 1, but we don't write it. Okay, so these are the types of things we'll be graphing. Never anything that's like y equals x squared plus 4, right? This has an exponent of 2. That is not linear. That will not make a line. Now, by the end of this year of math, you'll know how to do it, just not right now. We're going to focus on linear. Okay, so when we are graphing linear functions, okay, we're going to go through all of those sort of different pieces we've been talking about with functions. So let's say we have y equals 2x minus 3. This is linear. It has two variables, no exponent larger than 1. And we want to use the concept that we talked about earlier this week with function notation and being able to plug a value in and get a corresponding output value. Okay, so remember, we said there are an infinite number of values we could plug in for x. We could plug in 17, we can plug in negative 0.5, we can plug in 2,563,000. But we want to focus on some numbers that are going to sort of get us right here on this 10 by 10 coordinate plane, this 10 by 10 graph, so that we're not graphing something that's hugely ginormous, okay? And the best way to sort of do that is to start by picking input values of -1, 0, and 1. Right? You could pick something else. You could pick an input value of 1, 2, and 3. You could pick input values of 7, 20, and 42. Okay, but then that requires a larger graph than what I'm giving you. So there's 3 things that I have as my expectations here. Expectation number 1 is that it fits on the coordinate plane. So no drawing extra points that go off of the line. Oops, I'm talking and writing backwards. Okay, so it has to fit on the coordinate plane. No fractions. We don't want to plot any points that give us a fraction. Okay, because then we're going to have to approximate. And I've said this a lot, right? We don't want to approximate, especially when we don't have to. So no approximations, no fractions. Okay, and I want you to do 3 points. Now, 2 points is enough to make a line, but we're going to do 3 just to make sure we didn't mess up. Okay, any 2 points will make a line, but that 3rd point's going to tell us if we're doing it correctly. Okay, so once we've picked these starting values of -1, 0, and 1, we're just going to plug these each in just like we did for function notation. So instead of saying 2 times x minus 3, I'm now going to plug in -1 and say 2 times -1 minus 3. Now, I mean, I hope we could sort of do like 2 times -1 is -2, minus 3 is -5. But again, just like we did before, if you wanted to do 2 times -1 minus 3, it gives us an output or a y value of -5. And then we'll do the same thing with 0. 2 times 0 minus 3, which will give us -3. We'll then do 2 times 1 minus 3. Okay, and then once you get all of these values, we now want to remind ourselves that ordered pairs can be pulled out of a table, right? We were talking about that when we were talking about functions, that we can represent a table as points on a coordinate plane, ordered pairs. We could write it in a mapping, right? We have all these different representations we can use. So the most helpful to us in this situation is to then consider these as ordered pairs. So this is the ordered pair -1, -5. This is the ordered pair 0, -3. This is the ordered pair 1, -1. Okay, now we are then going to plot these points over here on our coordinate plane. Now, guys, plotting points is something we should definitely be able to do, but I get students who struggle with this. If you are not sure on plotting points, come and talk to me, let me know so we can fill in that information and make sure that we're plotting our points correctly, right? But they're always ordered pairs x, y, where our x-axis is the horizontal, our y-axis is the vertical. So we are going to go left 1 and then down 5. 0, -3, we are going 0 on the x, -3 on the y. 1, -1. Now, the key here is that it should be a line, right? We said linear functions make a line. And the key also is that it's not just these 3 points. There's an infinite number of points I could plug in here. And all of those points would fall on this line. Okay, so this line is really made up of a bunch of points that all could be plugged in to y equals 2x minus 3 and make this be a true statement, right? If I plug in the value, for example, let's see, 0, -3, if y is -3 and x is 0, I get a true statement. -3 equals -3. So all these points make that function true. When you draw your line, make sure you're drawing it across your coordinate plane. Make sure you're giving me arrows on both ends. I do not, however, need you to use a ruler and make it look perfectly straight because realistically, even if it looks nice and neat and perfectly straight, it's not necessarily exactly where it needs to be because all it takes is that ruler having a small angle to it. Okay, now once we know all this information, then this goes quick. So if I want to graph y equals 3x plus 5, what x values did I say would be good to plug in? We should be plugging in -1, 0, and 1. Okay, then we're going to take those values and we're going to start plugging them in for x. So I'm going to say 3 times -1 plus 5. What's our output value here? We get an output value of 2. Okay, now we're going to plug in 0. Okay, this one gives us an output value of 5. Okay, what's going to be our output value for 1? We should have done 3 times 1 plus 5, which gives us 8. We have 3 points. These will all fit on our 10 by 10 coordinate plane, and there are no fractions. So now we can plot these ordered pairs. Okay, so I'm going to plot the ordered pair -1, +2. 0, 5, and 1, 8. Because this is a linear function, what should our graph look like? This needs to look like a line, which we have, so that's good. So we can draw our line here. We're going across the graph, making sure we have our arrows. Okay, where this line represents a bunch of x and y values, that will make that function rule true. Last example we're going to look at today is what if we have 6x minus 2y equals 4? Okay, so now we're in this situation where this doesn't say y equals. It's not in a function rule format. And so plugging in those values is going to be a pain in the butt if we leave it in this format. So To help us with that, the first thing we're going to want to do is solve this for y. So remember, I told you that solving for y wouldn't go away, so here it is. If we want to solve this for y, what will we do first? We need to subtract our 6x from both sides. So those cancel. We'll get a negative 2y equals a negative 6x plus 4. Next, we're going to divide by our negative 2. How many places do we need to divide by that negative 2? We should be dividing in all 3 places. And so we'll have y equals a positive 3x minus 2. And now this is the new format we want to be looking at, right? These are the same thing. They're equivalent. They just look different. And this format is way more useful to us. So we're not going to look at this one anymore. Okay, and we are going to plug in the same starting values we've been using. Negative 1, 0, and 1. So when I plug in negative 1, what do I get out? We should get out negative 5, right? 3 times negative 1 minus 2. When we plug in 0, we get out negative 2. When we plug in 1, we get out 1. So we'll start plotting our ordered pairs. Negative 1, negative 5, 0, negative 2, 1, comma 1. Now I'm just realizing these 3 lines all happen to be going uphill because those are the values I happen to pick, but our line could be going any direction. As long as our final graph is aligned, then we're set.